Good afternoon, and thank you for joining us today, of course. As you all know, we've been developing and hosting these webinars on topics that we hope will be of interest to local governments with the aim of increasing your spatial IQ. Our focus today is on the COVID-19 crisis and how GIS data and technology is being used to respond to the pandemic. We'll take a historic look at pandemic mapping, which we hope will interest you. And then we'll dive into how AppGeo has been using geospatial technology to support communities during the pandemic, both on a project level and pro bono initiatives that we are supporting. Just to go through some logistics, currently you are in listen-only mode. The webinar is being recorded, and we'll share it along with the slide deck for you to share or review. So just to review the agenda real quick, we'll talk about the history of pandemic mapping, and then sort of give you a little bit of insight into what all the COVID-19 mapping that's been going on, and then get into some of the projects that we've worked on. Some of them are Sidewalk Suitability and using Esri's Survey 123 for contact tracing and health information. And then we'll talk about AppGeo Initiatives. We've kind of been involved with 3 pro bono initiatives at AppGeo. One is Courthouse mapping, Stop COVID-19 Together, and the Bring Food app, which we'll get into details with. Just to introduce you to the presenters today, Aaron is a sales engineer with AppGeo who joined the company about a year ago. In his role, he leads our webinar program, and we're really happy to have him here with us today. He's a pro at these webinars. He works with our current and prospective customers to provide demos of our technology and our capabilities. He's especially invested in our new Google for Local Government campaign. Prior to AppGeo, he's actually served as a GIS analyst consulting for some of the largest and most innovative municipalities in Massachusetts. Peter Limack, as some of you will know, is a GIS consultant at AppGeo, and he's been working with the company for over 7 years. In his role at AppGeo, he manages transportation, agriculture, municipal government projects, focusing on database management, long-term data maintenance, lifecycle and document management. Peter's also supported numerous state, local, and commercial organizations build their geospatial databases, networks, and enterprise systems. And of course, several of you know me. I'm a project manager here at AppGeo, been with AppGeo for over 10 years. And I manage local government clients and also work on web development projects. And of course, a part of the Spatial IQ team. And I'm also been involved with the Bring Food app project, and I'm the outreach manager for that, and hope to share that with you. And we're very excited about the app. So I will hand it over to Aaron, who's going to kick off the presentation. Thanks, Aaron.
Great, thanks, Priya. I wanted to start today with a quick look at how we got here and taking a look at the use of maps and cartography and tracking and understanding both epidemiology and pandemics. And it's really a science that goes back a few hundred years, in fact, despite all the recent improvements we've seen in the last few months. And it's really perhaps one of the most important fields where geography and spatial analysis really come into play. And that anytime we need to understand the relationship between people and location, maps can obviously play an important role. And when it comes to disease mapping, place is really one of the basic things we need to understand. The who, the when, the where. In this case, we're still understanding the why. But this is coming from the CDC Field Epidemiology Manual that has really taken a stronger look at how GIS tools can be used. But going back to where it all started, just a few quick examples to set the stage here for today. This is going back to the 17th century, where we see the plague. One of the earlier examples I came across, and it demonstrates how they were actually tracking some of their response to containment of people that had this disease way back in the 1600s. At this point, they were actually no strangers to this disease, having impacted Italy, which is what's shown here, in the decades before, and actually setting up borders in different containment zones, actually mapping those out for what may have been the first time. Jumping ahead another 100 years, this is a map many of you may have actually seen before. Dr. John Snow in London, demonstrating the clustering now of cholera cases, which actually led them to understand this little red circle here, the source of the outbreak, this Broad Street pump. Very interesting story about the use of mapping and actually understanding the source of the outbreak and how to potentially control it. Another 100 years forward, we can see a map at a truly global scale, this time looking at the spread of a virus, the H2N2, that may sound familiar. It's what actually eventually mutated down the road to be the swine flu that we saw several years back. But this notion of tracking things not just in a locality, but across the entire globe is something that became really important to understanding how these outbreaks became actual pandemics. And then lastly, a more modern but still static map and visualization looking at the more recent Ebola outbreak in West Africa just a few years ago, using cartography to show clustering and really highlighting at various scales level of detail. But again, all of these are static implementations, and as we're moving forward with GIS technology and of course the internet, we've entered a new era. And I think this recent COVID-19 pandemic that we're still in the midst of is a really strong example of many people using these tools for the first time. If they've been on the news, they've been pretty much on every government and statewide report. So let's take a look at some of the ways that the COVID-19 pandemic has been mapped, and this will lead into the ways that we've taken on some different challenges. So in different media, you may have seen standalone maps, interactive maps, different dashboards, data visualizations, and increasingly time series data, where you might be able to create the perfect map of a snapshot in time of where cases may be or where hospitalizations are occurring. But by the next day, that map is obsolete. So being able to take all that information, look at it over a larger time span, incredibly important. But one thing we want you to keep in mind when thinking about this is data alone can be misleading. The way that statistics are bucketed and represented can have a huge impact on how they're interpreted, and it's not an exact science. And in that sense, it's really important when you're looking at one of these dashboards, or maybe even creating one, or in part of an organization that's helping with this type of response, how the data is represented is almost, if not more important than the underlying data itself. So here you can see a few examples of some of these applications that are out there, some of the types of ways that this data is being visualized, from dot density maps or clustering maps to looking at information at the town or county or statewide level, to some charts that aren't maps at all, but looking at number of cases, looking at that curve, as many of you have undoubtedly been aware of. Just looking in a little bit more detail, here's an example from Johns Hopkins, their COVID-19 dashboard. It's been a very influential tool. They have a world map and a US map looking at all of these confirmed cases across the world and tracking that across time. Another very interesting implementation, this outbreak timeline, again, looking at the spread over a series of days, months, weeks, and where different hotspots are popping up over the entire world, going back to early February in this case. And looking at these data visualization dashboards, we may have interactive charts that help top decision makers really understand what can be safe and what can be appropriate when it comes to reopening. Understanding this data in depth and accurately is a huge part of that. So looking at some of the project implementations, we're going to have Peter Lemack join us.
I'm here.
Oh, perfect. Well, I'm going to hand it over to you to talk a little bit about, now that you've seen some of the maps and applications that are out there, how AppGeo has taken on some of these charges in our own work.
All right. Well, thank you very much for the intro. As Aaron said, I'll just kind of present a couple of the projects that our services team has been engaged on for some of our local communities. So as we think about public safety and starting to reopen our communities, one thing that's definitely on the forefront of my mind and the mind of others is sidewalk safety. We want people to be able to start getting out of their homes. We want them to start being able to go to restaurants and feel safe, navigating their world. There's been a lot of studies and a lot of applications that have been put out over the past couple months that identified the suitability of sidewalks and really kind of drilling into understanding the widths of sidewalks and classifying them to see, are they safe to socially distance, or are they too narrow for people to be safe while passing one another? So, this is just one example of an application from New York City where they took all their sidewalk data and they were able to analyze it and classify it. I provided the link. It's actually a really nice interactive application, and they do have some information about the work that they've done. So if you're interested in more, you can follow that link. For the city of Gloucester, Massachusetts, and the city of West Hartford, Connecticut, we did our own sidewalk suitability analysis. And, a very simple goal and objective was to identify how wide the sidewalks are, and then based on kind of our non-medical understanding of what is safe, to classify those sidewalks between 0 and 6 feet, 6 to 8 feet wide, 8 to 10, 10 to 12, and 12 and up. A sidewalk that is, very narrow might not be conducive to having a lot of people walking on it at the same time, where a sidewalk that is 8, 9, 10, 12 plus feet can accommodate more people. So what we did was we generated sidewalk widths from planimetric sidewalk polygon data, and we created a feature manipulation engine process, an FME workflow, that would effectively take these polygons, create a center line through the polygon, and then break them up into almost a grid-like structure. And then from that, we were able to measure the widths of each of the grids and aggregate them together. So as you can see in the two images above, once we had those widths, we were able to classify them. So that top image, that's Main Street, Gloucester. It's a very dense area. There's a lot of stores, there's a lot of restaurants. And we were able to depict to the city the areas that, these are very narrow and these are very wide. And we were able to run this analysis for the entire city. And our hope is to, be able to give this information back to urban planners or reopening committees so that they can do additional analysis. If I know where my highly trafficked areas are, if I know where my restaurant locations are, if there's metered street parking, I can compare the sidewalk analysis with those other, other features. And if you're thinking about shutting down a road or creating a shared street, or in the case of Davis Square in Somerville or downtown Hyannis, Massachusetts, to block off sections of parking, you can use the sidewalk data to kind of justify that. Well, there's a restaurant here, it's really narrow. Let's take a lane, or let's remove some meters for parking and extend that pedestrian area so people are more comfortable and more people can safely distance as they walk down that narrow section of roadway. So again, City of Somerville, where I live, they've done a lot of great work in closing off some of the roads, shutting down metered street parking, and making more pedestrian accessible areas. And hopefully the analysis that we've done for West Hartford and Gloucester, they can add that to justify their decisions for kind of increasing these shared streets. So the next analysis and the next project we worked on was contract tracing using Survey 123. For those who are unfamiliar, Survey 123 is an Esri application. It's really, really great at creating surveys so that people in the field can answer questions, can submit them back to someone in the office. What we did with the contract tracing application for one of our clients was to create a very simple form that their field crews in the DPW could every morning go out in the field, open up the Survey 123 app, and start tracking all of the all of their colleagues and all of the contractors that they interacted with. And over the course of the day, someone on a field crew might interact with 4, 5, 6, city employees, as well as maybe a contractor who's assisting with the replacement of a water line or something like that. And at the end of the day, you have documented all of the people that employee has come in contact with, and all that information is stored in a survey database in ArcGIS Online or the Survey 123 desktop application. And if someone does get sick, you can go back through and over the course of X amount of days, see all the people that they were in contact with. And then if you needed to, you could reach out and alert those folks that they might have been in contact with someone who was sick. The next application of Survey 123 was a COVID-19 health screening questionnaire. So again, for field crews, for people going out and interacting with others, it might be really important to have them complete daily surveys that basically says, hey, I'm not sick, I don't have any symptoms, I don't have a fever, I don't have a cough, I feel good, I feel healthy, I'm okay to go out and work with my colleagues. So we came up with a quick Survey 123 form where people could just answer a handful of questions. Really important, because I know most people are very sensitive about their medical information. Forms or surveys submitted could only be viewed by the person submitting the survey. So if I submitted a survey, I could only see my surveys. If Aaron completed a survey, I would have no way of looking at his medical information. There are some at the municipality who do have the ability to look at everyone's surveys. And we were able to configure the application that if someone does in fact answer yes to any of these medical questions, yes, I have a fever, yes, I have a worsening cough, that manager would be notified, and then that manager could go then contact the employee and say, hey, it's probably not a good idea for you to come in today. Why don't we just stay at home and just see how everything goes over the next couple of days. If you feel better, again, continue answering your surveys, and then we can discuss when you're at a later point. So those are just two quick Survey 123 surveys that you can develop to help make your employees who are congregating, who are in the field, feel a little bit more safer and accountable. Supplying internet to students in need. So we saw a lot of schools close and a lot of students of all ages forced to go home and complete their coursework over the past couple months in their homes. And in some cases, there are students, unfortunately, who don't have access to internet. And one of our communities, they wanted us to look at this, again, sensitive address information, and to map it out so that they could see clustering of students who don't have access to internet, to see if they could actually set up municipal Wi-Fi hotspots to supply internet to those students. So again, this was mostly just like a quick mapping exercise, a visualization. There was no advanced analysis of hotspots or grouping or anything like that. Mostly visual, and again, just a way that the town could provide for their students to make sure that no one gets left behind during this crisis. The last project I want to show is using MapGeo for sharing point of interest status data. So Imperial Beach, California, they provided in their MapGeo application, they provided points of interest with a feature search so that you could look at the location, you could look at the status of those points of interest, as well as do a spatial search. And what's really cool about the way that they enhanced MapGeo with their data was that you can then see what locations are open or are closed to the public. So folks, again, it's all about keeping the public safe and notifying them about updates and making sure that we reduce contact with others. So this is a really great example of using MapGeo to display information that the public can consume and keep themselves safe. So thank you.
Alrighty, so in this next section, I think Bria will kick it off talking about some of the initiatives that AppGeo has developed internally to respond to the pandemic in our own way.
Yeah, thanks, Aaron. I just wanted to say to everybody that I really feel proud to be part of this organization where we decided to actually help out and come up with solutions where we can respond to this crisis. And Rich Grady, our president, was really determined to do something. So we're actually going to show you three projects that we've been involved with pro bono. One of them is this Boston Courthouse jurisdictions map, and this was actually a map a project that the Greater Boston Legal Services and the Suffolk Law School's Legal Innovation and Technology Lab are in the process of working on developing an online resource for people in Boston to go to the courthouse and get information about which courthouse to go to. So one of our colleagues and developers, Calvin, actually dug into this and gave his time to work on this project. It was not trivial because, firstly, of course, the reason was that you can't go into the courthouse when we were under quarantine or lockdown to some extent, and the courthouses were also closed. But even identifying which one to go to file any of your legal paperwork was difficult. So he had to dig into a lot of data, which could be voter lists, could be address lists, could be different legal documents out there about that, and then using all of that information, he then developed this map which gave you the specific jurisdiction. So then you could put in your address and it would tell you which courthouse you'd need to go to. So it was a pretty cool project. We have a blog post about it that you can take a look at if you're interested any further. And I will pass it on to Aaron, but before he gets into the next piece, I just want to give you a heads up about Bring Food, which Aaron will also be talking about. Again, I've been really, very proud to be part of this project, and it's been so rewarding. You might have heard about it because we did share it with our MapGeo clients about the app and it being free and available for anybody to use. But it's been great to interact with the people who are actually doing this really important work of getting food to people, and talking to them and seeing how happy they are with what we've done and how they've used it. So I will let Aaron take on. I just want to let you all know that if you know of anybody who could use this application, please have them get in touch with us and we can give them free access to it. So I'll let Aaron take over.
Perfect. Thanks, Priya. And we'll be back to Bring Food in just a couple minutes here, but I first wanted to share with you a little bit of the work we did for UCLA, way out in California, far from any of our home offices. But in the wake of the virus, the researchers and top epidemiologists there wanted to put together a really comprehensive nationwide dashboard. And this is all running on Google Maps technology for the visualization and the display. And they had reached out to Google, UCLA that is, asking, we have all this data, we have our top team ready to go, but we need some help taking it to the finish line when it comes to the visualization. And as a Google Premier Partner for Google Maps, Google then reached out to us, AppGeo, and within pretty much 24 hours, we were on the phone providing some consulting pro bono to bring this app to the finish line. And it's a pretty powerful web application. You can check it out if you go to Stop COVID-19 Together. If you search for that, you'll find this whole dashboard. And it really brings together complex cartography with either county-wide or statewide, even some point data for the entire country, just at so many different scales. And clicking on a particular county, you're able to access kind of a timeline dashboard, all sorts of statistics, compare to other cities potentially, and really see how different regions are managing the spread. So a pretty interesting project in that it was very quick turnaround from when the call came in to when we were on board to help, and something that we're proud to have been a part of, being one of the top resources to this day for the mapping of the outbreak. So to go back to where we left off with Bring Food, to give you a little background on this project, AppGeo wanted to have a really specific way to help when it came to the coronavirus and all of the communities around where our own employees live that have been impacted, in some cases very greatly. And one of the ways that we were able to do that is working directly with some of the food pantries and understanding where the issues were around food insecurity. And a major problem that arose in the wake of the virus was that with this pandemic going on, which is both a health crisis and for a lot of people an economic crisis, there was never greater demand for some of these services. However, they had no pre-existing home delivery infrastructure. They were set up for people to show up, pick up their groceries, and head home. But suddenly bringing people into a small place, especially if these are vulnerable individuals themselves, is problematic. So what do you do? And you can't come to them and they can't come to you. Well, that's where their kind of network of volunteers comes in. But delivery systems are complicated. You have people distributed all over a city, all over a town, and God knows the roads around Boston aren't the easiest to navigate, even in the best of times. So that's where the Bring Food application comes in for delivery optimization. So the way that this works, and we'll show you a little more in depth here in a minute with a live demo, is we receive, roll through the application, someone can submit a list of addresses for delivery, and through the Google geocode engine, we ensure that the address shows up correctly on the map. And then using Google routing technology, we're able to quickly calculate the most efficient way for a predetermined number of drivers to reach all of those locations. And we're able to then visualize the routes on a map or a printout that would have that driver's list of addresses in order of the most efficient way to reach them all. And we've been doing some beta testing with various communities. One quote that we had was very striking to us. What took them hours in terms of the planning to get all of these deliveries to the right place is now done in under 5 minutes. And I think we can demonstrate that with our demo here. I'm going to go in and actually show you the live version. So this is the Bring Food dashboard. I'm going to start it from scratch just so you can get the full experience here. So it starts by submitting the data, which would be like a spreadsheet, just a list of addresses of recipients. In this case, I created some fake sample addresses just to show you how it works. In this stage of the application, the data has been consumed from the Excel sheet, and we're just going to tell it what each of these headers is. So this lines up with the street address, the city, zip code. In this case, we're in Mass, and this is actually pretty interesting. The number of boxes or parcels to be delivered. This is a new functionality we added, which takes into account not every car is going to be able to fit the groceries for 100 people. You might fill it up yourself going to the grocery store once. So being able to define the delivery size will help with the routing optimization to ensure that that's given priority when we're doing the calculation. And then you could have additional fields like the client name or the drop-off location that won't necessarily feed into the routing, but they will be available in the final outputs. So say someone needs it put to the back of the house, they would see that when they're doing the delivery. So when we hit assign here, it's now geocoding all of those addresses, putting them onto the map, and here we see pins that represent all of our homes. And if we saw something that was out of the ordinary, we could click on it, do a revision, change the town. It will update on the fly. We don't have to go back into our data. If there was a location that, say, is in there erroneously, let's say we're not delivering to Belmont, we could dismiss and it would take it out of the running. The other interesting variables here that we will define before completing the routes are setting where the distribution center is, because where everyone's starting from, picking up from, is going to impact, obviously, their choice of route. So in this case, I'm just going to put in a grocery store for an example. What's nice here is we use Google Autocomplete, which I just need to put in the name of the store. It knows that's where it is on the address right here in Medford. And now that that's been determined, we can pick either the max number of stops or the max number of routes. So this could be determined by, I have 7 drivers to work with. I want them all to have a route to deliver to. I would like exactly 7. Or potentially max delivery size. My vehicles can only fit 10 bags each. So based on what we told it earlier about how many packages they were planning on getting, that would take it into account and again use the right optimization. But let's do an example here where we have 7 drivers and optimized routes, and you'll quickly see why this application is so helpful. It's running the math now, and within seconds we have all 7. They're shown in different colors. They all start here and in the most efficient manner drive to the section of town that they need. Some may have more or less depending on what's most efficient, where the clustering of homes are. And what's cool is we can go back and change this. Say maybe we only have 3 drivers that day. We're a little light staffed. It'll re-optimize very quickly to find the most efficient way now for 3 people. And of course, you could go the other way too. So you might not necessarily think going from Cambridge to Assembly Square here in Somerville taking 90 and 93 would be the fastest way because it's longer. But because this is based on Google's live traffic and roadway speed, this is actually the faster way to go, even though just looking at the distance alone, you might not assume so. From there, you could export to a CSV, which would, once I open it up here, let's see if it works. Yep, give you each of the routes and the stop number and the address, any other details that we had put in there is all retained. That's something you could print out or even feed into a door-to-door routing application going further. But we would appreciate any questions. Again, we're ready to launch the public version of this application very soon. It's going to be on a sign-up case-by-case basis, but the new website, bringfood.care, will be live, I believe, by the end of this week, if not very soon. So we'd encourage you to check that out and share it with anyone who you think would benefit from this application, and we're going to be continually developing it and improving it as time goes on. So from there, I'd like to hand it back to Priya just to wrap us up and then take us into the questions and answers if we have any for today.
Thanks, Aaron. I hope you enjoyed this presentation. We were sort of hoping to give you a quick glimpse of pandemic mapping and COVID-19 mapping, and also show you how we've responded to COVID-19 at AppGeo. We are here to help you. As you always know, Spatial IQ support is available for you to answer your questions. We're happy to brainstorm ideas and help solve problems, and with the main goal of raising your spatial IQ. So please be in touch. It looks like we might have a couple of questions, Aaron. So let me just take a look.
Yep.
This one's for Peter. Peter, is the sidewalk analysis something that we could implement as a theme on MapGeo, and what data would you need to implement it?
Sure. Yeah, you can definitely put it on MapGeo. That's actually a really great place for it because you can, compare it to all of your other information that you have there. And all you need is planimetric sidewalk data. Our tool runs on polygons. So if you have that, that would be great. I imagine though, if you had, lines or something like that, we could probably figure out a way of making that work. But the easiest path forward at this time with the tools we built would be just a polygon data set.
Another one for you, Peter. Can these the contract tracing, the Survey 123 applications be used by local governments in town hall, and how would we set it up?
Yeah, absolutely. So, the setup
I think it kind of ties into another question about whether it can be hosted by AppGeo or the town's ArcGIS online account.
Right. So it would probably be hosted on the town's ArcGIS online account, though we could help you set it up. And Survey 123 is new for most people. It was definitely new for me, so we could provide some training on that and help you get it configured. But really, once it's up and running, the next steps for those at town hall who are kind of monitoring the situation, that data can be added into web maps. It can be added into dashboards, or like I said, it could just be emailed out to, people in the health department or administrators who are, are in charge of kind of making sure that town employees are safe.
I guess this question I can take. I think somebody wants to know whether, I think our school district is making deliveries. Can we have access to the application? Absolutely. In fact, I don't know if they're on the call, but North Andover, one of our clients, the school district is doing deliveries, and we gave them the access to the application, and they were very thankful, because just sorting through the addresses and figuring out how to make, the whatever 100 deliveries a day can be a bit challenging. So yes, absolutely. So if you have a school district that is doing deliveries through the summer, or even plan to in the fall, then yes, please have them get in touch with us and we can set them up. I think that's it, Aaron. We're always here for you, so please do drop us a line if you have any questions. And thank you so much for being here today and checking out what AppGeo has been doing as a response to COVID-19. Thank you.
Thanks, everybody. And we'll be able to distribute the recording of this webinar after the completion, so be on the lookout for that if you missed anything or want to share it around between your own group.